For section 7.6, we're going to look at both learning objectives together, A and B. We're going to graph square root and cube root functions, and then talk about their domain and range. So the first thing you want to note is a square root function will always have a very similar shape. It looks something like this. It's kind of like a half of a sideways parabola, and it's just a little swoosh right there. A cube root is similar, except it kind of goes in both directions. So this graph is right here. On the cube root, it still has the same swoosh this way, but it also goes downward that way. And they will always look in this similar format. They just might be on different spots within the graph paper. Sometimes you're going to be asked to graph a function and fill in the table of values. So here we're going to do a square root function. Remember, the base shape of a square root function looks something like this. Sometimes it'll start at the origin, sometimes it'll start up here, sometimes it'll swing on over here. We just have to graph it and see. So to do this one, let's put 0 in for x first. So y equals 1/2 the square root of 0. Square root of 0 is 0, times 1/2 is 0. If we put in 1, y equals 1/2 the square root of 1. Square root of 1 is 1, times 1/2 is 1/2. Let's put in 2. 1/2 square root of 2. All we're going to do for this one is I'm going to put the square root of 2 over 1, multiply straight across. The answer is the square root of 2 over 2. For 3, let's put in the 3. Again, put this over 1, multiply straight across, square root of 3 over 2. And the last one for 4, square root of 4 is the number 2. 2 times 1/2 is 1. Now if we sketch out some graph paper and graph this function, see, we have to have x's all the way over to 4, and our y. So that'll be our x and our y. Plotting the first order pair, 0, 0 is right here. 1 and 1/2 is about right there. 2, and then the square root of 2 over 2, if you put that in your calculator, the square root of 2, and then divide that by 2, you're going to get that the answer is about 0.707. So I'm going to go to 2.707, a little higher. If you put the square root of 3 over 2 in your calculator, you're going to get about 0.866. So at 3, I'm a little higher. And then when I hit 4, I'm at 1. So this shape would look something like that. So that's how you graph it. Now, if we talk domain and range, the domain and the range on this, remember that domain is going to be your x values and the range are the y values. So I'm going to do this down here. Domain are the x's, the range is the y's. I'm actually going to start with the range first. So the y's mean when do the y's start having activity? And if you look down in this quadrant and in this quadrant, where y is -1, -2, -3, and so forth, there's no graph activity here. It's all plain. There's nothing going on. So the range, the y's are not going to be any negative numbers. We do not start seeing any answers until the y's equal 0, which is right there. So we have y answers at 0. We have y answers here, here, and here, and here. And it's going to keep going up. So when you look at it, you're going to see that the graph on the y-axis, if we just go looking upward, we don't see any graph activity until 0. So it's going to be that y is greater than or equal to 0. Now the domain works in a similar fashion, but that's the x-axis. So if I look at the x-axis and I travel, over here in the negative x's, there's no activity. So my domain has no negative x's. When do I start seeing it on the graph paper? When x equals 1, I start seeing graph. I see graph, I see graph. So the domain is when the x's in here are going to be greater than or equal to 0 also. Okay, let's actually graph one more by hand. This is a cube root function. So remember, roughly the cube root functions look something like this. It's a little more shape to it. And let's put in -2. So I'm going to go here for the y. -3, and I'm going to do the cube root of -2. Now for this one, I'm actually going to have us go into the calculator and type this. The cube root of -2, there is a button we can use, or I can just type -3, the -2, cube root is 1/3 power. So I'm going to go and type on my calculator negative 3 times, in parentheses, a negative 2. Raise that to the caret key of 1/3. And this decimal is going to be about 3.8. Okay, let's try negative 1. And again, I'm going to use the calculator for most of this one. So negative 3, and I'm going to put to the cube root of negative 1. Again, in my calculator, I'm going to type negative 3, then I'll do the times, and then I'm going to put in parentheses a negative 1. I'm going to raise it to the caret key of 1/3. And when you do that, you're going to get that the answer is 3. Now, if we put 0 in there, you're going to have negative 3, the cube root of 0. Cube root of 0 is 0. 0 times negative 3 is 0, so that's a nice clean one. Let's put in 1. When we put in 1, we have negative 3, the cube root of 1. By the way, the cube root of 1, what number 3 times is 1? Well, that's 1. 1 times negative 3 is negative 3. And then the last one is going to be putting in a 2. And I'm going to use my calculator for this one. And when I do that, I get negative 3.8. So if I graph this, the shape is going to look roughly like this. See, at negative 2, I'm going to go up to about here. Negative 1, I'm at 3. Then I'm at 0. Then at 1, I'm at negative 3. 2, I'm way down here. So it's kind of stretched out. That is what the graph looks like. Now, the domain and range on this one is a little more clear cut. So the domain on here, again, is all the x values. And here's a nice way to tell. Just travel along this x-axis here. If you travel along the x-axis and eyeball it, you always see the graph is somewhere on the plane, which means there was never an issue. If there's a break in the graph where there's a gap and you can't see anything, for example, if this would have a break right there, that means there was a domain issue at this number because they tried to put in negative 2 and it didn't work. But that's not the issue. It's clear and continuous. So the domain here is going to be all real numbers. There's no issue. The range, or the y's, are really how high does this graph go. So for this one, I'll just come on the y-axis and I travel up and down the y, and I notice there's always graph activity on the negative y's and positive y's. There's no issue. This thing goes as low as it can go and as high as it can go. So the range on here is all reals. Any cube root function has a domain and range of all reals. Okay, I'm going to look at just 2 more of these, and we're going to use the calculator this time to graph it. So I'm going to go into the graphing of y equals, and at the y equals prompt for the graphing calculator, I'm going to hit the square root button and then type x. Make sure I hop out of that, and then I do +2. To hop out of it, you may have to use your right arrow key. And when you do that, here's what the graph will look like. It'll roughly look like this shape. So you can just transfer that over once you hit the graph button to your paper, and then just state the domain and the range. So the domain, again, is all the x's. And if we look at the x activity, if we're traveling on the x-axis here, on the negative x's, there's no graph yet. There's no graph yet. It doesn't start until right here. When the x's hit 0 is when I have graph activity. So the domain is all the x's greater than or equal to 0. The range, I'm going to do the same way. When is there activity? On the y-axis means range, so I'm coming up. There's nothing on the negatives. There's nothing on the negatives. There's nothing when I hit 0. There's nothing when I hit 1. The graph doesn't start until I hit the number 2. So the range on this is going to be y is greater than or equal to +2. The last one I want us to look at is this one. So for typing in your graphing calculator, this is a little trickier. So go to the y equals button. And I want you to type this. Do a parenthesis, x minus 1, caret key, 1/3, and then a -2. When you do that, here's the graph you're going to get. It looks something like this. Now, one of the key features to this graph is this turning point right here actually happens, if it helps you on the graph paper, at a +1, -2. So if I trace that over, that's kind of the key things I want to get. Now, again, the domain for this function are what the x's can be. And if you travel along the x-axis, I'm traveling this way, I see the graph below me. I see graph, I see graph, I see graph below me. Now it switches to above me, but I always see graph. There's no place I didn't see any graph. So the domain, that means for the x's, is all real numbers. The range, again, as I travel on the y-axis, I'm down here in the negatives, and I see graph to the left. I see it to the left. Now I see it to the right. I see graph to the right. Now be careful, as I get up higher, there really still is graph. It's just off my paper, and it's going out to infinity. So the range on this one is still going to be all real numbers.